All right, in this lesson we're going to be looking at distance and midpoint. Distance is the length of a segment from one endpoint to the other endpoint. Now, keep in mind that lines do not have a distance because lines go forever and ever in two directions. So since the lines do not have a start and end point, you cannot measure a line. Notice also that whenever you're naming a segment, you put the bar over the two endpoints, but whenever you're referring to the measure of a segment, there should be no bar above the two endpoints. The distance formula, it's derived from the Pythagorean theorem. And the distance formula is used to find the length of a segment. And the length of the segment is going to be the distance between those two coordinates, the coordinates of the endpoints. Midpoint is the point on a segment that is the same distance from both endpoints. And the midpoint formula, it's actually another coordinate. It's not a value, it's a coordinate. It's another location. So you add the x coordinates, divide by 2, add the y coordinates, divide by 2. All right, so given these two coordinates, we want to find the length of AB and the midpoint of AB. All right, so to find the measure of AB, we're going to use the distance formula. So we do x2 minus -5, x2 minus x1 squared, plus y2 minus y1, 1 minus -3 squared. 2 minus -5 is 7, 1 minus -3 is 4, 7 squared is 49, 4 squared is 16, 49 plus 16 is 65. So the exact measure for segment AB is the square root of 65. However, if you were asked to approximate the measure of AB, you would take the square root of 65 and get approximately 8.1. The midpoint of AB we get by adding the x coordinates and dividing by 2, adding the y coordinates and dividing by 2. -5 plus 2 is -3. -3 plus 1 is -2. And then the -2 over 2 we can simplify to -1. All right, using the same steps, different coordinates, we can find the measure of this segment AB by subtracting the x coordinates, squaring that quantity, subtracting the y coordinates, squaring that quantity, and then adding those two together. -4 minus -2 is -2. -2 minus 3 is -5. -2 squared is 4. -5 squared is 25. 4 plus 25 is 29. So the exact measure of segment AB is square root of 29. If you were told to approximate that measure to the tenths place, you would just take the square root of 29 and you would get approximately 5.4. And then to find the coordinate of the midpoint, you would add the x coordinates, divide by 2, add the y coordinates, divide by 2. -2 plus -4 is -6. 3 plus -2 is 1. -6 divided by 2, we can simplify to -3. And then lastly, there may be some scenarios where you're given the midpoint and one endpoint. If M is the midpoint of a segment RS and they give us one of those endpoints R, we can manipulate that midpoint formula to find the coordinate of the other endpoint. So the x coordinate of the midpoint is equal to the sum of the x coordinates of both endpoints divided by 2, just like the y coordinate of the midpoint is equal to the sum of the y coordinates of the endpoints divided by 2. So we plug in the value for the x coordinate of the midpoint, plug in for x sub 1, the x coordinate of the endpoint that is given, and then solve for x2 by multiplying both sides by 2. 2 times 2 is 4, and then subtracting 5 from both sides. So the x coordinate of our endpoint is -1. Repeat that process for the y's. So the y coordinate of our midpoint is 4. The y coordinate of the endpoint that's given is -3. So to solve for y sub 2, we multiply both sides by 2. We get 8 equals -3 plus y2. To isolate the y subscript 2, we add 3 to both sides, and we get 11 for the y coordinate of that other endpoint. So the coordinate of the endpoint would be -1, 11.